Very good morning, students. In previous class, we discussed about types of matrix, definition of matrix, and types of matrices. Up to what are the matrices you have learned about square matrix, rectangular matrix, zero matrix, row matrix, column matrix, and you have learned about how to write order of matrix also. Yes, now you will learn about sixth type of matrix, that is diagonal matrix. Diagonal matrix means a square matrix in which all the elements except the diagonal elements are zero is called a diagonal matrix. For example, let me take matrix A. 2 by 2, it's a square matrix. If you observe, diagonals are 8 and 7. Diagonal elements in diagonal position are 8 and 7, but the rest are zeros. Even here also, root 3, root 2, root 5. Order is 3 by 3. Means it is a square matrix which contains diagonal elements are other than zeros. So the rest elements are zeros. You can consider some more square matrix which are diagonal matrix. Again, I am repeating, as we discussed yesterday, you people learn about definition of matrix, order of matrix, and what are the types of matrix, that is square row matrix, column matrix, zero matrix, square matrix, rectangular matrix. And today you are learning about diagonal matrix, that is a square matrix condition in which all the elements except the diagonal elements are zeros is called a diagonal matrix. Means other than diagonal elements, the rest are zeros. Yes, A, B are given. These two are square matrix which contains diagonal elements are other than zeros and the rest of elements are zeros. Elements means, you know, the numericals or algebraic terms are called as elements. Now you people learn about scalar matrix. A diagonal matrix. Just now you learn about diagonal. What is diagonal matrix? A diagonal matrix in which the diagonal elements are equal is called a scalar matrix. Means we know what is diagonal matrix. In diagonal matrix, if the diagonal elements are same, equal, then that is called a scalar matrix. Observe here, it's a 2 by 2 square matrix, and as easily as we learned just now, it's a diagonal matrix and the diagonal elements are equal, same. So it is a scalar matrix. Even here also diagonal elements are same. It's a diagonal matrix. So a diagonal matrix nothing but scalar matrix when the diagonal elements are same. So it is a diagonal matrix. So that's why we can assume that a unit matrix which you will learn is a scalar matrix. A unit matrix is nothing but a scalar matrix because diagonal elements are same. Yes, now you will learn about another type of matrix, that is identity matrix. Now, just now you learn about diagonal matrix, scalar matrix. Now you learn about identity matrix. You know, in earlier classes you learn about identity and additive identity, multiplicative identity. Additive identity is nothing but zero. When we add zero with any number, we'll get same number. So multiplicative identity means when you multiply one any number, will get same number. For suppose 10 into 1, 10, 10 plus 0, 10. So addition, additive identity, multiplicative identity. Similarly, in matrix also we have identity matrix. That is a square matrix in which the diagonal elements are 1. Diagonal elements are 1. The rest elements are 0 is called identity matrix. Let us take examples. Matrix A. Generally, we will represent identity matrix as I, students. So 1 0 0 1, it is my identity matrix 2 by 2, order 2 by 2. And one thing observe, it is nothing but a diagonal matrix. It is nothing but a scalar matrix also, as per the definition. Now it is identity element in 2 by 2. Identity matrix in 3 by 3. Condition, it should be square matrix, students. It is identity matrix in 3 by 3. Now identity matrix in 4 by 4 order, that is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So observe here, students, it's a square matrix. Diagonal elements are 0 1 and diagonal elements are 1. The rest are zeros. So this is called identity matrix. So from this you people learn about the types of matrices like row matrix, column matrix, zero matrix, square matrix, rectangle matrix, diagonal matrix, scalar matrix, identity matrix. Now you learn about what are when two matrices are equal. When we can conclude two matrices are equal or equality of matrix. And then after you learn about addition, I mean some of the operation matrix. Actually in operations we have addition, subtraction, multiplication. But now you will learn this class only additions. Then after further class you learn about negativity of matrix and subtraction and multiplication and its properties also. Right now you learn about equality of matrices. Now you people learn about equality of matrices. When two if A and B are two matrices, not only two, we can say more than two also, in general two are said to be equal if first one, if their first one orders are equal. I mean if they have same order, the next corresponding elements are equal. If their orders are equal and their corresponding elements are equal. I mean to declare or to say or to compare two matrices as equal or to check the equality of matrices. Let us take two or more matrices, in general two, but more also we can. If two matrices are A and B are two matrices are said to be equal, if their orders are equal, I mean they should have same order, and then their corresponding elements should be equal. Let us assume one matrix as A, B, C, D, E, F. This is 2 by 3 matrix, 2 rows, 3 columns. Then another matrix to frame or to say same equal, corresponding elements should be same and order also should be same, students. Then we can say if these two are same, then we can say A equals to B, because corresponding elements are same. A we have here, B. First element in first row is A, second element in first row is we can represent the elements, each elements as like this. Here A element is first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column. I mean here it should be corresponding elements should be same and order should be same, then they are equal. So we can name like this, students. In general here A we can write the first element in first row and first column, B is first row, second column, C is first row, third column, D is second row, second column, D second row, first column, E is second row, second column, F is second row, third column. Like that we can write the order of the particular element, corresponding element also. I mean that is called element, which place it is at which place it is kept, it's kept in that particular matrix also we can write. This is the way to check the equality of matrices by comparing with the corresponding elements, and order should be same, then only we can say equality. Then the both of the matrices are equal. If two matrices are equal, we can find the unknown values also. These are the types of matrices you have learned till this class. you'll get some home assignment and some work problems we'll discuss right now, and based on this some home assignment problems you will get. Right now we'll discuss some problems based on this, whatever topics you discuss till this class, till this topic. Now let us we discuss how to write order of matrix and how to place the each and element in a particular row and column, and how to frame one matrix by given property. For example, let me consider one matrix, okay, that is given as a matrix A is given as, let me assume one matrix minus 2, 5 in that row. First I am writing rows, 0 rows, elements in rows, 0, root 5, 3, comma 6. Now let me consider, let me write the matrix A as minus 2, comma 5, 0, comma root 5, 3, comma 6. But observe, we can write its order. What is the order of this matrix, students? Yes, order of matrix A equals to how many rows? Generally we will write my order as rows, number of rows by columns. Yes. Now consider, check how many rows are there. 1, 2, 3. 3 rows by 1, 2. 2 columns. Now the order of this matrix is defined as 3 by 2. Now order of this matrix is 3 rows, 2 columns. But number of elements, total number of elements also we can write, students. Total number of elements are 3 rows, 2 columns. If you multiply number of rows into columns, that many elements are possible. See, if you observe 3 by 2, 3 2s are 6. 1, 2, 3, 4, 5, 6. These are. Now what is the place of each element? How can we represent? Representation of each element of matrix A. See, students, what is representation? At which place minus 2 is located, 5 is located, 0 is located, root 5 is located, 3 is located, 6 is located, we can write. Simply, any element is defined as A, I, J. In general, I stand for the row number, which row it belongs. J stands for which column it belongs. Okay, students? In general, write rows by column, like that. Now, what is the which row it belongs? We can write minus 2. It belongs to first row, first column. So we can write minus 2 as A11. That is nothing but minus 2. A11 means the element which belongs first row and first column as per our matrix is minus 2. Then after A12, first row, second column. What is first row? The element which belongs first row, second column. 5. This is representation of each element. For suppose if I wrote A21, second row, first column, that is 0. So we can represent A22, that is root 5. Then after, so A22 means the element which belongs to second row, second column, because we have only 2 columns here. Number of rows are 3. So now A31, third row, first column. That element we can represent 3 as per our problem, as per our given matrix. A32, that is 6. This is the way the representation of each element of matrix A. So here, once again I am repeating. First, order of matrix. Next, total number of elements. Next, third point, representation of each element of given matrix. So based on its order, each and every Each and every element of matrix we can represent like this. In a matrix, in a given matrix, A11 nothing but the element which is in first row, first column. A12 means first row, second column. A21 means second row, first column. A22 means second row, second column. A31 means third row, first column. A32 means third row, second column. Like that we can represent the position of each and element, order of matrix, number of elements in a matrix based on order. You'll get some problems based on this. Please do as home assignment. Now let us discuss a problem. Construct a 3 by 3 matrix whose elements are given by Aij. Just now we discussed Aij stands for A is an element in which I row and j column is defined as 1 by 2 within the bracket modulus, because it never negative, that is why we should take positive, I minus 3j within the bracket. So what is the matrix? How to frame a matrix which is 3 by 3 element? Now just now we discussed 3 by 3 matrix will be a square matrix. We can represent each element in the form of Aij. I mean, how many? I means I stand for rows. How many rows are there? 3 rows. Means we can take I value as 1, 2, 3 because number of rows is, so we can write order as rows by columns from this basic concept 3 by 3 here as per given problem. So rows will be 3. 1, I value may be 1, I value may be 2, I value may be 3. Now let us we take columns. Here also 3 because number of columns as per the by the order, given order of the matrix, again 3. It's a square matrix. Now let me take first element A11. I mean first element which belongs to first row, first column equals to, as per the given condition, this is the given condition, 1 by 2 modulus. I value how much, students? 1 minus 3 into 1. Modulus, it may be, sometime it may be negative. As per our problem it is always positive, but no rule it should be positive. It may be irrational, it may be any real number. No rule always negative, positive like that. But as per our condition it is always positive because modulus is given, as you know. 1 minus 3 by 2 modulus. Modulus minus 2 by 2. So A11 first element, the element which belongs to first row, first column is minus 2. If you remove modulus it will be 2, as we discussed earlier in earlier class also, you know. So what is first element here? The element which belongs to first row, first column of this 3 by 3 matrix is 1. Let us continue and we'll find all the values whatever required. How many values we should find? 9, because number of elements are, how many are there as per problem? 3 by 3, 9. So we have to go to A12 because first row, second column. Again same process, 1 by 2, 1 here. Now we'll 1 by 2 minus, I value is 1, no change. 3 into 2 will do directly, students. Again it will take more. 1 minus 6 within the modulus by 2, that is 5 by 2. What is second element? First row, second column element? Yes. Now A13, 1 by 2 of modulus. Now 1 minus 3 by 3 into 3 modulus, that is 3. 1 minus 9 by 2 within the modulus, that is 8 by 2, that is 4. As per our problem, the first row, third column element is 4. So we got one row, completely one row elements we got. First, in first row, first element is 1. In first row, second element is 5 by 2. In first row, third element is 4. So in this manner, we will find all the 9 values. Then after, we'll frame the matrix. Once again, I am repeating. Take the property, check the order of matrix. Based on that, I value, j value we can consider and find the element which is in first row, first column. Yes, we got first row, second column, first row, third column. Means one row elements we got in the matrix. What are right? Then after find 3. I mean total 9 elements we need to find because 3 3 is a 9. We have 9 elements as per the given problem. So now A11 is 1. We'll write together. As per our problem, A11 is 1. After A12, I mean first row second element, second column element is 5 by 2. A13, that is 4. We got 3 elements. Based in the similar manner, we need to find 6 more elements by using the given property and frame the 3 by 3 square matrix. So these model problems you will get as home assignment. The next we will discuss about the properties. So first row is completed. Now we'll go to second row. A21. A21 means the element which belongs to second row, first column. So same process, students. 1 by 2 modulus I value 2 minus 3 into 1, same process, that is 1 by 2 modulus 2 minus 3. As we know, A21 is 2 minus 3 minus 1, but it becomes 1 because modulus A21 is 1 by 2. Now we will find A22. A22 means, students, second row, second column. So I and J are equal to 2. So we have 2 minus 3 into 2. Same process, students. So 2 minus 6 within the modulus 2. So A22 is here 2. It is 2 minus 6 4 because modulus is there. Though it is minus 4, it becomes plus 4. Modulus of minus 4 is 4. 4 by 2 is 2. I mean second row, second column element is 2. Now second row, third column element, that is again 1 by 2 modulus I value as this 2 but J value 3, students. Yes. Now modulus 2 minus 9 within the modulus by 2. So A23 is 7 by 2. As we know, if you remove this modulus, though it is negative, it will become positive 7 by 2. So we got second row element also. Second row first column 1 by 2. Second row second column 2. Second row third column 7 by 2. So we got second row element, one more row. So total 6 elements we got. Again I am repeating. First to find elements which belongs to first row. After by using property, because it is 3 by 3. 3 by 3 matrix means 9 elements are there. We found first 3 elements which belongs to first row. After by using property we found a second row element. Now we'll find third row element. No rule to do like this. You can find column wise elements also, that is up to you. But in general we'll write order of matrix as row by column. That is why I'm doing rows wise. But no rule. But don't get any confused while applying. So we got even second row element. In second row elements write together like this. Second row first element is 1 by 2. Second row second element is 2. Second row third column element. Second row second column element is 2. Second row third column element is 7 by 2. Write together, friends, as like previous, and then write frame. Find 3 more which are third row element. So second row first column element is 1 by 2. Second row second column element is 2. Second row third column element is 7 by 2. So we got 6 now. So how many students still we need to find? Yes, 3 more, because total 9 elements are there as by the order of matrix. It's a square matrix. It may be rectangle, same procedure, students. No change at all. By using property of matrix, we can find the matrix by using this method. Now we are finding the elements which belongs to third column. Third row. So we need to find A31. Third row, first column. Same again. 1 by 2 modulus I value 3 minus 3 into 1. That is 3 minus 3 modulus 3 minus 3 by 2. That is 0 by 2. 0 by something always, students? Yes, as you learn, that is 0. Now A32, third row, second column, same procedure. 1 by 2 modulus I value 3 minus 3 into 2, 6. Again we have modulus 3 minus 6 by 2. That is A32 element. The element which belongs to third row, second column is 3 minus 6 we know, minus 3 by 2 modulus if you remove 3 by 2. Now last element which is required, third row, third column. Again same property will apply, students. 1 by 2, 3 minus 3 into 3 within the modulus. Now apply modulus 3 minus 9. As we know, that is modulus minus 6 by 2. If you remove, that is 6 by 2. So we have A3 element as 2 1s are 2 3s are 3. So we got all the 9 elements again. So first check what is the order of matrix, what is property of matrix. Then by the order of matrix it contains number of rows are 3, that is why I value should be 1 2 3. Number of columns also 3, j value should be 1 2 3. Substitute and find A11 element, A12 element, A13 element, A21, A22, A23. After A31, A32, A33. Frame in the form of matrix. This is the way to construct the matrix when the property and the order is given. So what is A31 matrix as per our problem? Yes, 0. A32 matrix, A32 element 3 by 2. Then A33 element, students? Yes, that is 3. Now frame the matrix. What is the order of matrix? Yes. So give a name in capital letters, that is up to you. I am taking P, matrix P. So we can write the required matrix P as use square bracket or a small bracket, that is up to you. What is first element? 1. First element in first row. Second element in first row. Third element, I mean 1 by 1, 1 by 2, 1 by 3. Next, 2 by 1, 2 by 2, 2 by 3. Next, 3 by 1, 3 by 2, 3 by 3. So what is the order of matrix? 3 by 3. It's a square matrix. Name it as P. If they mention anything particular name, you can write that. So this is the procedure to find the matrix when order and the property is given. So till now what you learn now? Order of matrix, how to frame one matrix. Now equality of matrix I will explain and then we'll conclude. If 2a plus b, a minus 2b and 5c minus d, and then one matrix is given 4c plus 3d. Students, here one matrix is given which is 2 by 2 by 2. It's a square matrix, equals to 4 minus 3, 11, 24. Then find the values of A, B, C and D. See students, here two matrices are equal given. As you learn, orders should be equal. Yes, orders are same. So, and the corresponding elements should be same. Already they are equal given. So, if these two matrices are equal, so from that by above, so according to the problem, we can write 2a plus b equals to 4. A minus 2b equals to minus 3 because corresponding elements are equal. By solving these two, we will get a b values. Now again students, 5c minus d is equals to 11. Then after 4c plus 3d equals to 24. We have here also. If we solve both, you will get c and d values. Let us. You know elimination method you learn in earlier class, previous classes. So by in elimination method we should equate any one variable. If you observe, if you multiply by 2 this one, b's are easy to cancel. Or else equate a variable, that is up to you. So we have 4a minus 2b equals to 8. Then after we have a minus a plus a minus 2b is equal minus 3. If you cancel each other, we have 5a equals to 8 minus 3, 5. A is equals to 5 by 5, which is 1. We got a value as 1. So now let us find b value. So now put a is equals to 1 in any one equation. That is, I will take here a minus 2b is equal minus 3, up to you. Or else take 2a plus b. 2a plus b is equal 4, up to you. Here we have a value 1. 2 into 1 2 plus b is equal 4. Now b is equals to, as we know, so b value 2. So we have here a value is 1, b value 2. So by solving, by first compare the corresponding elements, we got two equations solved by using elimination method, which you learned in previous class. So now while comparing these corresponding elements, we got A value as 1, B value as 2. Now let me compare these two elements. We have two equations. Equate D elements. I mean, again apply elimination method as we discussed just now. Then after 3